Good morning, dear participant, and welcome again in this session. Today is the 8th session on this ongoing faculty development program. And today our resource person will be Dr. Upinder Kaur. And yesterday she was also with us. And I hope that the content which was presented yesterday, and we have provided all of you all the entire Jupyter files and other files which are being presented yesterday. And I hope that you have used all these files. If not, you should try all these files. And if you have any challenge, please always feel free. And also, today's session will be more interactive because now in this session, we will apply for machine learning. Okay, so you should enjoy the entire session. And Dr. Upinder Kaur, welcome in this session once again. And all of you are very familiar because yesterday I have give more detail in brief introduction. So today I skip the brief introduction so that the entire section can be used for valuable and informative knowledge. Thank you to all to join this session. Now, Dr. Upinder ma'am, over to you.
Okay, thank you, sir. Thank you very much. First of all, thank you again for giving me this opportunity to conduct this session in the second day. So first of all, the topic for the today is machine learning using Python. So actually, sir has told me to give a practical demo of the machine learning task. So definitely I will cover one project today. And it will be the basic project so that everyone join this FTP can learn the basic concept, how we can implement machine learning in the simple task. So before starting with the practical project, we will have some discussion about the basic concepts regarding the machine learning. So first of all, I just want to confirm my PPT is visible to everyone and my voice is audible.
Yes, mom, it's clear, mom.
Okay, sure. So machine learning, it is a buzzword nowadays. Everyone is hearing about machine learning, AI, deep learning, and some other complex terms are also available in the market. So we will start with the simpler term, that is the machine learning. So basically, what is machine learning? Basically, there are a number of definitions that we can scroll the internet or Google or Chat GPT. We will find number of representation about the machine learning. We start with the very basic definition. Machine learning is a programming computer to optimize a performance criterion using example data or the past experience. It can automatically detect patterns in the data that to use uncover patterns to predict the future data or the outcomes. So here is a simple diagram in which we can see that in the one example, we are having a human being. We are doing our daily task. We are learning from the experience, and from the experience, we have developed a skill. That is the behavior that we follow in our human being. And what the machine learning does, machine learning has the raw data on the basis of some models. So we can able to predict from this past data, and that model will able to predict some numerical figures that can be used for the further prediction or some other task. So this concept is similar with the human learning. So now instead of human, we are training our machines, our computers to learn from the past data that we have today. That is freely available nowadays. Number of data resources are there. So you can get, if you want to get the data for the machine learning project, you can scroll the Kaggle, you can scroll the internet, or you can, if you want to get a real-time data, there are number of resources as well. You can also create your own data. So before doing this, we will understand why we need this, why machine learning is important today. So machine learning based on the statistic, that is basically attempting to find the relation between the input and output variables. For example, input is what? It is the data that is generated in the past, and output is what that is required for the future. So we are developing some kind of prediction based on past data for the future. So who are using this? Organization, governments, we are having a lot of data on the internet nowadays available. Information from the data is being used to take major business decisions or some lower level decisions, some kind of thing. Everything, everywhere we are using AI, machine learning, deep learning nowadays. At higher level, database perspectives and predictive models are really start using now. So machine learning is the most popular technique for creating this prediction and the prescription model. So we understand what is machine learning and why people are using it, because it is helping automation our work. So if human can think, machine can also think, and on the basis of your past experience, and machine will learn from the past data and predict some value that is close to the future prediction and nearer to the real time data. So basically, we have two types of machine learning approaches that we are using, supervised and unsupervised. There is a little difference between these terms. Supervised and unsupervised. What is supervised? Supervised is where you have the input variables and you have the output variables. Using any algorithm, what you need, what is the requirement is, uh, just you need to map the values. Just you need to map these values from input to output. Our goal is to draw a line that can able to justify and that can able to predict the data that is closer to that point. Similarly, unsupervised learning is what? It is a machine learning approach in which you have input data but no corresponding output labeled variables. There is a no labeled data. So the goal of unsupervised is to develop a model that can understand by themselves only. Means we are not having any labeled data in case of unsupervised learning. So visualization of these two approaches in the next example. So in this example, if you see it clearly, see, input is what? This is the input. Input is what? We are having some images. And what we are going to do with this images, we want our machine will able to learn what this object is. So what we want to do, we want to train our machine to understand what this object is. So what we are doing, we are giving the input images to the algorithm, that is some machine learning algorithms. And on the machine learning algorithms, there is something written over on top that we are having a supervisor. Supervisor is the algorithm we can say, or a trainer we can say, that can have training data set and desired out. So supervisor help in this complete algorithm because we are having a labeled data. The term used here is labeled data. So these images are labeled one and we are using some machine algorithm. We are processing of these algorithms and on the basis of data processing, we are supplying this input data to the machine learning algorithm as an input. After the learning patterns, machine will get the label from these classes as well as uh, problems. So machine will generate some value. That value is known as the output. If machine understand the basic features from this image, for example, it is a circle in shape, it is a red in color, it is the height of this, basic features from this, and after that machine will able to recognize that this particular object is a tomato. So this is the simplest example that we can understand how machine learning algorithms can work. Are supervised in this, we are having the labeled classes of this. We are having number of images of the different objects and we labeled these images. On the basis of that labels, computer will understand the feature, the constraint related to that particular object and able to distinguish that particular object into one object. For example, it is a tomato, it can be images of a car, it can be images of a dog, cat, anything. You can get examples of these kind of things, any uh, simplest example from the internet. So Let me. So I think this example is okay to everyone. It is a just simple example. We have some images. We put some algorithms for the data processing and extract the feature from it. We understand this feature to our model with the labeled data, and machine will give you some output that said it is a tomato or it is not a tomato. On the basis of the feature, whatever the output we will get, we can understand that machine will able to understand what we are giving you as an input. Okay, so next, just wait. So next, in the supervised machine learning, after the example, basically we are doing two type of things in the supervised machine learning. One is the classification and second one is the regression. So first, understand the basic difference between these two. What is the regression problem and what is the classification problem? For example, if I give you one simple example, yes and no. I have given you some choices. On the basis of you have two options. You can say yes or you can say no. This kind of problems we can say as the classification because you have two classes, yes and no, true or false. You take it or you don't take it. If you have two classes and on the basis of these two classes you are going to classify how many people are in the yes class or how many people are in the no class, then this kind of problem is known as the classification, where you have some categorical stuff or categorical data. So this kind of problems in the supervised machine learning came under the classification thought. So there are number of examples as well. For example, in this we have the credit scores. Credit scores, we want to differentiate the people with the low risk for the credit and the high risk for the credit. So see, there is a boundary line between the high and low. So people in this box are under the low risk, what is one class, and people here are in the second class, that is the high risk. So either are you in this way or either are you in this way. So in this way, we have to classify the number of people on the credit scoring. So this is one example. Instead, we say and simply understand the categorical data, we call it as the for the classification basis. It can be useful in the pattern recognition, face recognition, character recognition, and number of medical diagnosis problems. Okay, so next we have the regression. Next we have the regression problems. Regression is what? Where we have some predictions, some numerical data where the category is not available. We are not having any distinction between the different classes or one or two classes, yes and no. This kind of thing is not available. For example, house price prediction, weather forecasting, prediction of a particular price for an object. So where we have some numerical data instead of classes, these kind of problems came under the regression term. So regression, which what we want to do, we want to draw a line that can able to distinguish the multiple data points, and this line is known as the boundary line. So this kind of problems where we have to predict some numerical value or prediction kind of problems, that problems came as regression problems. So for example, here what we are doing, price of a used car. So we want to get a second-hand car, and we want to predict the particular price that can be suitable for this. So we have choose the two parameters, X and Y, car attributes, for example, mileage, and Y attribute depend upon X, what will be the price of that car. So this kind of things cover in the regression problems. So some other examples like weather forecasting, I have already discussed sale forecasting, budget allocation, product pricing. These are the some of the examples for the regression. Okay, so now we will understand what is unsupervised machine learning. So earlier we discussed with the supervised, under supervised, we discussed the classification and regression problems, categorical and non-categorical. So next that we have here is the unsupervised machine learning. Unsupervised, where we have non-labeled data. Non-labeled data. Non-labeled means here we are not having any random classes, we are having no labels here in the data. We are just having the raw data. We don't know the outputs. We are going to train the data, and machine itself will learn from this large volume of data and able to categorize that data. Classification is there. So in this example, if I explain, see, we have some raw data. In this raw data, we have different colors: orange, red, green, blue, and this is a jumbled data. So after the training of the data, translation about what is this kind of data, for example, we are having different classes of data. So what machine algorithms will do, they learn the different patterns from this. Upon the basis of that pattern, analyze the data and grouping, clustering of these data into different data points. For example, we categorize or classify red, blue, green into the different clusters. So this is the simplest example of the unsupervised learning. So in other words, if I want to give some other example, I will say, for example, we have an image as an input, but this time this image is not a labeled one. I will see the number of features. For example, what is the shape of the image? What is the color of the image? What is the color intensity? It covers the complete area or not. So these are the different features that I extracted from that image. And after that, I'm going to predict this image is similar to object X, or this image is similar to object Y. After that, we will check from some output relevancy. If it is correctly, then we will group it into that one. Otherwise, we will check again. So this kind of thing that will be done in the unsupervised machine learning. So what algorithms came under the unsupervised machine learning? Basically, the algorithms came under these are the clustering approach. In the supervised, we are having the classification and regression problems, but in the unsupervised machine learning, we will go with the clustering approach. So clustering is basically the simplest, that is the k-means, KNN, k-means, these kind of algorithms that we used in the clustering purpose. So in my session, we will just discuss some more about the supervised learning approaches. Before doing this, we will understand to make a machine learning project, and to start with the machine learning project, what is the machine learning pipeline? So how we can proceed step-by-step approach during the machine learning model. So first, we are having these steps that we need to start with the machine learning project. Problem number one, we have to find a problem for which we want to develop our machine learning model. Then we need a data from where we learn or where the machine will learn, because the nature of the data is a very, we are getting the data from the number of resources. Data may be different kinds of different formats of data, raw data. So we need to do a lot of pre-processing task. After that, we need to split the data into the two categories, train and the test. Then we decide which machine learning model we will use. After running that model, we will validate and check the accuracy of model, and then we test this model for the deployment and the production. So these are the basic steps. We will discuss in detail one by one. In the step one, what we will do, convert your business problem into statistical problem, clearly define the dependent and independent variables, check whether we want to predict or interferes, means we want to predict or we want to classify. So first of all, we decide what is the problem, how to deal with it, how machine learning help it, what are the different variables that is related to the project. After that, we have to check the availability of the data that we are having in it. In the data, we are having number of things. I'm giving you some example. For example, if you have a small data, if you have a small data, then might be possible best machine algorithms will not give you the as per the desired accuracy result, because data is important in this. And if you are having a large volume of data, then whatever the machine learning algorithm you are using, you will get the exact and best results. And never any algorithm you are using in the machine learning. It means data is very, very, very much important in this kind of task. Either deep learning or machine learning, data is have the so much most priority. Because if your data size increases, your model accuracy is also varying in number of ways. So data is very much important, and you need to check the data in one single format when we are using for the machine learning task. The next approach, after the finding or finalizing your data formatting, you need to do the number of data pre-processing tasks. What are these tasks? For example, filter the data. For example, the missing values, the values that is not part of your, for example, we are having 15 columns and you need only 10 columns for the data analysis part or for the machine learning training, then we will filter out the unnecessary data that we don't need. So this is the filtration task. Aggregate values. So where we have some missing values, we can do some kind of data imputation task, like we will impute some values, fill an a, drop and some kind of things are there. If you have lot of missing values in the data, we need to treat it with some of the methods to impute the data. If you are having some outliers in your data, then you need to detect it. Otherwise, it will give you a very false predictions, depend on the weakness or not a better quality of the data. After that, if you are having some categorical data and you want to convert it into the regression type, you need to do some kind of encoding 0 and 1, some kind of this. This can be need as per the desire of the project. So we can do some kind of transformation. Then we have feature reduction. If we are having number of 15 to 20 columns, we are not requiring all these. So we are not including that one in our project. We will exclude so that it will minimize our computation task. So data pre-processing, the next important task after the data collection. Okay, the next one is, it is also very much important to differentiate whatever the entire data you have selected for the machine learning project. You need to categorize data into the two classes, training and the testing phase. For example, you can go for the 80-20, you can go for the 75-25, you can go for the 70-30. It depends what kind of data you are using for the testing and for the training task. And after that, we are going to implement our model. Model is basically a different kind of functions. On the basis of that, we will get from some output on the basis of some input value. So it is a simple example. Y is equal to fx. Fx is the function that is going to predict some value of y on the basis of some value that is available in the x. So this is the simple example of the machine learning, some kind of equations that we are following in the machine learning models. So after that, once we implemented, we selected that particular model, and that model undergo the training process and give us some output as a result or the prediction. So we will check. After that, we will check the performance of that particular model. On the basis of that, how accurate your model is, it go with the underfitting or overfitting. So we will check the performance metric that will tell us how good your model is, how better your model is, how the performance of your model. Okay, so after that, we will go for the testing of your model for the production and output of this. So you will do this. After that, you can deploy it and go for the testing of your model. So After that, these are the simple things that I want to discuss before starting with the project. I will just recall. First, we understand what is machine learning, why we need it. There are two types of machine learning we are discussing here, supervised and unsupervised. And we will doing the project based on the supervised machine learning today. And it is classification and regression problem it supports. Then we have a unsupervised where we have a no labeled data. And it can be done with the help of clustering tasks. And after that, we have gone through all the steps that is required to build a particular machine learning model. So this is all about the PPT. Now I am going to share my Jupyter notebook with all of you. So let me share it. Yes. Okay. So my screen is visible, sir?
Yes, ma'am.
Okay. So the project I'm discussing today is the customer churning production model. It is a simple example. We can understand if you are doing machine learning for the first time, then also you can able to understand this. We are implementing all the supervised machine learning tasks in this project. So first of all, before doing it, we will understand what this project is and what kind of data we are having in it. So customer churning project. So this is the CSV I am having. So under this CSV, let's understand this, whatever the data we have. Customer churning is what we are going to predict when the customer is leaving our product, our company, our organization, and on what reasons and on what basis. So these are the columns we are having in our project. Row number, that is the indicator of the serial number, customer ID, surname, credit score, geographical area, gender, age, tenure, balance, number of product, has a credit card, is an active member, expected salary, exited or present. So these are the columns that we have today with this CSV file. And this is the data that we are having. And on the basis of data, we are going to predict the particular person is going to with your organization or product or will leave you on somehow or some reasons. So let's start with the project. Yes. So first of all, before starting with this, we need to have some important libraries. The main library we are using here, this sklearn library. On the basis of that supporting libraries, some we are using here the NumPy, Panda, Seaborn, Matplotlib. These are the basic libraries that we need in our machine learning project. And the main library we are using at the sklearn. Because in the sklearn, we are using the number of different machine learning models. So I will explain why we need this one. We are using the sklearn for the pre-processing task, that is data processing we want to do. So here we are using the label encoder task here. And next, sklearn.model selection. And under this train test split we want to import, because we want to split our data into the two parts, training part and the testing part. That's why we need this code. So next line is the sklearn linear model. We want to implement the logistic regression here. And in the logistic regression, we want to import this library from sklearn.linear model, import logistic regression. The next library we need to implement the naive biased supervised machine learning approach. And under this, we are using the Gaussian naive bias. The next library we are using to implement the decision tree, that is the sklearn.tree, import decision tree classifier. The next we are using here from the sklearn.ensemble, random forest classifier. The next we are using here from sklearn.neighbor, import k-neighbor classifier. And next we sklearn for the SVM is the support vector machine. And one major here we are using is the XGBoost. So these are the main of the machine learning libraries that is used in with the sklearn that we need for our project. And before using this, we need to install sklearn library first. After that, we are going to import these things in our project. So I have checked that the validation, for the validation, we need some accuracy matrix. So for accuracy matrix, we are using the sklearn import matrix, and under the matrix, we are using the accuracy score. We are using the AUC, area under curve. We are using the confusion matrix. We are using the ROC, area under curve. We are using the ROC curve. We are using the recall score. These are the things that we need for the model validation. Okay, so first we are going to import these libraries. So I have done successfully because I have already installed all of the above mentioned library for my project. So next thing, this is the simple example how we can install it. For example, pip install and sklearn. Pip install XGBoost. So whatever the library you want earlier, yesterday we have discussed, we can write pip, we can write conda, pip install, conda install, and then the library now. After that, that particular library will get installed in your system. Again, I am using the Jupyter notebook today. For this, I will share this notebook with all of you with the data I am having. Okay, so once I have loaded or imported all the particular libraries that we need for my project, now I will upload my data file. So for data file, I am using the pandas library. So we are using the pd.read_csv, and this is my file name and it is available here. Churn modeling.csv. This file I'm going to use here, churn modeling.csv. So if it is available in somewhere else location, then here you need to write the path. Yesterday I have told copy path and just pasted it. So this is the method in the pandas. So in this way, we are converting this CSV file into the pandas data frame that we will use further in our project. So I'm going to run this one also. So I have uploaded my data using pandas. So if you want to check what data is uploaded, I have run this one. So this is the CSV file that is available with us for the project work. So see, this is the raw details that is shown here. So these are the number of columns, that row number, customer ID, surname, credit score, geographical area, gender, age, tenure, balance, number of product, has a credit card, is active member, expected salary, exited. So this 1, 0, they are converted using the data pre-processing task. Okay. So once I get the data uploaded and available as a data frame, so let's explore our data first. So what we have in the data. So first we will check how many number of rows and columns in my data. So we are having the 10,000 rows and 14 columns. For this I have written df.shape. So it will provide me the number of rows and columns. And if you want to check what are these columns and what are the data type of these columns in my data sheet, so you need to write data frame name dot info and bracket. So when you run this code, what information you will get these details. That row number, column number 1, total number of rows here 10,000. Not null means it is not miss value, and the data stored is in the integer 64. This is the data type. Similarly, see here the surname, it is the object 1, geographical area is the object 1. So you can able to identify where we can apply the numerical value and where we cannot, because in object you can't use the numerical function. So you can able to understand the number of columns, the nature of the column, and the data type they store. Okay. After exploring it, if you want to check for the null value, because before starting the machine learning project, we need to check you have any null value. So yesterday we have done this also, is null dot sum. It will give you the count of the number of columns where we have the null values. So I have already done the data cleaning task. So it is showing you that we are having 0 rows where we have null values. So there is no null value in this data. Okay. If you want to check, this is just an example. If you want to check, for example, yes and no variables. If you want how many people say yes, how many people say no. To want to count the number of unique values in particular column, for that we are using this value underscore count. For where we are using to count this one, data frame and the column name. In the data frame DF, there is a column exited that indicates that that particular customer is available or exited from you. So we will check the number of count on respective of the number of values here, unique values here. So what output we are getting here? It said that this column has two values, 0 and 1. And under 0 from the 10,000, we are having 7963. And in the 1, we are having 2037. So this indicates the number of rows in this particular value. So that's why yesterday we are using every time value underscore count, because it will provide you the number of count in the unique values in that particular columns. Okay. So after that, if you want to check the statistic of our data, we will use data frame dot describe. So it will provide you the total number of rows in the count, mean value, that is the average, standard deviation, minimum value, maximum value, and the quartile range from 25, 50, 75. And it is for the all the columns. So you can have an idea and where we are going for your averages. So we will have an idea about your data set now. Okay. If you want to check the number of unique values in your data set, so it will provide you, it can help you to find out the duplicate values as well. For example, row IDs. If there is any number repeated, it said number of unique values, the 10,000, the total number of rows are 10,000. So it indicates that there is a no duplicate in these rows. And in case of customer ID, all the customers are unique. So there is a no duplicacy in data set. So any unique you can use to check to find out the number of duplicate values if you have. Okay. If you want to check the number of columns, yesterday we have done this df dot columns. So you will get all the columns that is available in your data set. Okay. So before doing the machine learning project, first we check the data visualization of our project. So we will have some C1 library. Under this, I'm using the pair plot function to check some kind of correlation between the different variables and different data that we have in our project. So I'm going to run this one, sns.pairplot. Pairplot is an inbuilt feature that is available in the C1 library. It will take 1 to 2 minutes. So let it get some output. So I'm waiting for the output. Let's wait. We will get the output over here. It is still running. Yes, we get the output here. So we will see. I'm just maximizing it. So see, the row number is there, the customer ID is there, credit score is there, age is there, tenure. So we are having the scattered graph here. The pair plot show us the scatter plot, and it also show that. So we can able to find out the correlation between the multiple columns. So where we have find out any idea where we have a significance columns. So you can find out this thing from this studying this pair plot. Okay, so after studying this, we have the columns. We can understand the values that is stored in our data set. So now we will check the various combinations of these columns before doing that modeling task. Okay, so in this, we are having finding out the relationship between the area, estimated salary, and the gender. We want to find out some relationship between these columns, geographical area, estimated salary, and the gender. Okay, when you run this, you are getting this plot. What it indicates that in France, we are having equal number of gender bases and we are having the equal number of salary variations. So why we are distinguishing between the gender and gender here? Because we are finding out the customer churning product. We want to find out which gender is most susceptible to us. So we are finding out the relationship between the salary, between the area and the ages of that. Okay, the next combination we are trying for the age and the expected salary. Because if we are in the 18, we are if in the 15, we are having a less salary. So we are going to buy less products. But if we are having some fixed or some better salary, so we are going tune with that organization or company. So we are finding out this relationship as well. So we are checking out the relationship between the age and the estimated salary. So we see that in the age of 50s, 20s, we are having the maximum salary and we tune to with this organization has a better chance for this. So this is the expected salary range, this is the age range, and this is the basis of the data that we have. Okay, the next is that age group, and do you have that customer or that customer leaved you? So we have 0 and 1. 0 indicate that that person leaved you and 1 indicate that you have that person. On the basis of that count, it will provide you the data. So on the basis of that, we have this data. It indicates that in the age group of 18 to somewhat 30s, we are having less number of exiting. And in age of 50, above 50 and earlier, we have a more probability of exiting. So we can finding out the relationship between the age and the exiting property. So it can able to learn as if the person is growing in growing age or above 70, so have more probability to leave the organization or some other factors we need to engage them. So this is the kind of decision we can take from this kind of graphs. Okay, so one more relationship between that, the gender and the estimated salary. Because here we are seeing that male and female ratio is almost equal and the expected salary and the salary they are having are almost at the same ratio, because salary is also one of the factor that is corresponding to the customer churning process. Okay, one more relationship between the balance we want to check, gender and the balance. Because why we are checking it? Because if our data have the more number of males or data have the more number of female, then we can have some biased results also. So that's why we are checking about the balance between the number of entries for the male as well as the female. Okay, so next we are having the age that we have already checked one. So next we have age and the number of products, because there is a lot of variation between the items of the particular organization or the company and age. For example, in the age group, we are linked with the books. In the other, in the college life, we are linked with the mobile phones, we are living with the tablets, etc. So depend upon the age, our necessities and our products will change. So we can find out the relation between that also. So in this, we are able to finding out the number of product under 18 and number of products used by the 80s or 90s also. Okay. So next we are having the number of product purchased by a person with their expected salary. For example, if you are having greater salary, you will buy more. If you have a less salary, you will buy less. So that's why we are finding out one of the relation between that, the number of product we are having, and the person that is purchasing that product having this some estimated salary. Okay. Then we have a relation between the age, tenure, and the gender. For example, tenure is the duration in which that person is linked with that particular organization, and how long you can connect with that. It depends upon the age of the person, requirement of that person. It means if person is about to leave, you have an idea that about 70, that person is going to leave your organization. So we can offer something that can more retain to your organization after that age also. So we have a relation between that multiple factors also. Okay. So there is one more issue with the geographical area and person is connected with your organization or not. So is an active member and the particular geographical area. So see here we are using here the data from this France, Spain and Germany. So we can find out the relation between the basis on the basis of gender, that is the number of active members here. Okay, so is active member exiting your, so what is the ratio between that? We can find it out here. So why we are using and why we are using the data visualization of these are the factors. Why? Because we are having the CSV files, CSV file having the number of numerical data. And if I'm showing you this Excel file, it is very difficult to finding out some relationship, some um, foresight of your data that how many customer from Germany, how many customer from France, how many customer from Spain, and how many are females, how many are males, expected salary kya hai, what will be the age group. So it is very much difficult to judge from the Excel. It has the 10,000 rows. So in one go, I can't check all the 10,000 rows. So that's why data visualization is very, very important factor before analyzing the complete data. And why I'm using these columns, it depends upon the data and depend upon the problem. In other problem, for example, if you are using some healthcare data for the disease prediction, maybe your data will be changed, your columns name will be changed, your data value will be changed, and your correlation dependent independent variables will be changed. So you need to go through with all that before starting with the project. Okay. So this thing, data visualization, is also very, very important because it will give you some idea what kind of data we are having and how we are exploring it and how it can able to give me the accurate and predicted, most predicted value. Okay. So there is one more factor. For example, if person is having a credit card, so if has some credit card, there is a more credibility that person is linked with us and will purchase something from your organization with connected with you, because we are giving some of the offers on the credit card, discounts of there, coupons of there. If that information we are having, we can correlate with that. Okay. So after that, data visualization, we have done all the necessary combination that we are looking for this data. We have explored all. So we get an idea that it is a balanced data. We have equal number of males and female. Even if we had equal number of their expected salary, there is a balance with data. So then we can go through with data. Otherwise, we need to do some kind of modification, some kind of changes and imputation to the data to make it a balanced or more vital data. Okay. So after that, we are using some kind of label and coding in our data. Why we are using and why we are doing it. For example, on the basis of we are having 3 geographical locations here and we want that geographical location, we want to figure out that data. So what we will do manually label and according to these so that we are able to identify these rows, that is particular area. So what we are doing here, it is the categorical data. geography, and gender. We are calling the label encoder function. And what we are doing here, we are transforming it into the particular labels. For example, we are having 3 geographical area. So we divide the 3 categories, 1, 2, 3. So if we have Spain, it will count 1. If we have Paris, it will count 2. If we have Germany, it will count 2. And by this code, it will convert all the rows. For example, now see, we have France, we have Germany, and we have Spain. When I run this code, what it will do, it will convert the entire column into 1, 2, 3. So we will convert that data, categorical data, into the numerical data with this label encoding feature. I hope you understand why we are doing this task.
Sorry.
Yes,
So how do you know which one is gonna be 1 and which one is gonna be 2 and which one is gonna be 3? Because you didn't specify it anyway.
No, I'm not specifying here. It will convert the first one as at first. For example, the first column, we will see here. The first column we will change. See here the geographical area. See here 0, 1, 2. I called 1, 2, 3. So by default it will count 0, 1, 2, 3. Sorry, 0, 1, 2 because we are having only 3. So first, whatever the column it will face, it will term it as 0, and respective all that column rows will be converted 0, and the next value will be converted as 1, and the last value will be converted as 2. It will go column row by row. So we are not putting here ki convert Germany is 0, convert France is 1. No, it will do the automatically label encoder. So it will see how many categories. If we are having 4, it will go with the 0, 1, 2, 3. If we are having 5, we will go with the 0, 1, 2, 3, 4. So it will go automatically. We are using just label encoder. We are checking the number of categories we are having, and on the basis of that, it will convert that into the numerical labels so that we can find out that. Hunch. Okay. So after that, again, I'm using the keys. Keys are what? These are the column headers. For example, row number, because now onwards we will use that one for the some other tasks. See. So see, in this data, we are having the row number and the customer ID. And all of them are the unique one. So 10,000, 10,000. But we don't need anywhere row number. So we are going to drop this one. So what we are doing here, we are dropping all the unnecessary columns, because if we have some data, we will do the computation. If we have minimum data, we will do the less computation. For that purpose, unnecessary columns will be dropped. So in this,
sorry, how did you determine the unnecessary columns then?
see, ma'am, we are having the row number. Row number is what? It is just a serial number. Serial number is not going to give me any indication that particular person is here, that particular person is going to leave that company. So that's why I'm using this. I'm going to drop this column because it gives me no significance or having this computation in my project. So that's why surname I'm not using anywhere in the analysis part. Customer ID, I'm not using anywhere in the analysis part, the data visualization. Earlier I had done. I have keep all these that have significant in my project, and other non-significant that is not relevant or not used in this. I'm going to drop all these columns. So I'm not using that. And here one more thing, I'm using the in place is equal to true. Why I'm using in place is equal to true? I'm using this because whatever the changes done under this, it will be saved in this data set that I have used in the previous, that I have uploaded here. Otherwise, it will change this one. Just wait. In this data frame, it will change it. If I'm not using in place is equal to true, it will reduce the columns that in not particular copy only, not in the entire data frame. That's why I'm using the in place is equal to true here. Okay, now we are very close.
Sorry, one last question.
Yes.
Are you then working under the basis that this is clean data, so you don't have duplicates on this? Because if
No,
you drop in
I'm
customer ID, then you
yes.
don't you can't use that as a unique
Just wait,
differentiator, right?
just wait. I just want to say, in the earlier I said I have cleaned my data, so it is not having any duplicate or missing information. But now I am not doing that task. I am just dropping or eliminate the columns because we are having 10 columns. We are not using 10 columns. We are using 7 only. So we will fix with the 7 only. All the unnecessary we are going to drop it one. We are not going to do it with the machine learning model. That's why I am eliminating some of the columns here. So it is not cleaning part. It is just whatever we required in the project and what we don't. If you have some rows that we don't need, we can use the skip rows also that we discussed yesterday, skip rows. So here I am just explaining why I am not using these. If you have some columns, for example, these are the columns. I don't want this column number 1 or column number 10. So you have the option. You can drop that particular column from the data set if you don't want to use in the machine learning model. Just simple as that. If you don't need any column, you just drop it. It will not drop from data set if you are not using the in place is equal to true. Is it okay, ma'am?
Yes, thank you.
Okay. So after that, we are again checking the number of the distillation. It is the density plot. It is basically the check out the density of the number of data points in these particular areas. So I'm checking once again before implementing the model. So what are the density curve we are having in our data? Just wait. Yes. Actually, we have changed some of the data. So it gave you the density. So it will provide you the number of variables. See, density is there. So it will provide you the this curve that is smoothen curve that is just wait. This is the smoothen curve here. In these are the data points. So it will provide you the idea that the data you are going to do for this analysis part, how much data points are available to you. So that's why we are checking the density here. So it is not mandatory every time you need it, but you can check. If you want, you can check with that. Okay. So after that, once again, we are not using this last column here. We are dropping the exited one because we are going to check this one. So I'm not using this one more column here. So after that, here we are moving to the next phase. We have done the first part of our machine learning model. We selected the, just wait. Yes. So I'm repeating here. So until step 3, we are done. We have understand the problem. We have understand the data. We done all the pre-processing tasks. We have visualized the data as well. So next step after that, we are going to select the type of percentage we are going to select for the training and testing set. So again, continue with that model. Yes. So now we are going to check how much data that we want to keep for the testing and training. So I'm using these variables. X train, Y train, X test, Y test. X and Y are the values. Under these variables, we are going to keep the data points for the X and Y as well for the training as well as the testing part. So it is doing automatically, just we are giving the ratio. We are using the 80-20 ratio here. We are calling the function here train underscore test underscore split, and the variables we are using here X and Y, and the test size we are keeping here 0.2, means 20% of the data is considered for the test part and 80% of data is considered for the training part, and whatever the points came under the data for the testing and training, we are keeping it at the random state, means randomly the points will be taken. So that's why after that, what we are indicating, how many points will cover under the train and testing the shape. So you need to check this one. What it indicates that from the 10,000, 8,000 are for the train and 20,000 are for the testing, because we are keeping the ratio 80-20. So 10,000 votes, 8,000 are for the training purpose and 2,000 for the testing purpose. Once we're done with this, now we are starting with the model here. So we are going to implement number of models here. First, we will start with the simple logistic regression. So logistic regression, it is simply what we are going to do in the logistic regression. We are simply going to plot a line. That line will able to distinguish between the different, for example, these are the data points I am indicating in this example. So this particular line will help us to distinguish between these two types of data points, that customer will remain or customer will churn. So we want to predict that particular line under this and the data we have. So that is the logistic regression we are going to implement here. To implement that line, we need to call this function. The function name is a logistic regression. Wait. The function is logistic regression dot fit. L is capital, R is capital. Logistic regression dot fit, and the two variables I am going to pass it here, X train and Y train, because we are going to train the model. And the result of this model, we are going to keep in this variable log regression. After that, we will check the prediction. Now the training will start. We will call the log registration. First, we call the model. After that, we check the prediction. And we will check the prediction on the training data. And it will go under the number of epochs and will train the model and understand the data that we have provided for the training purpose. And after that, we are checking the test data for the number of production points. Test data. For this, we are checking, we are changing the testing data log regression dot predict. Now the data set here we are going to change here from training to testing phase, because training is done in the previous part. So after that, during this, our model is going for the training phase, and under this we are going for the testing phase. And after training and testing, we are checking the accuracy of that particular model. So we are going to find out the white test predicted and the total test predicted. So we are going to find out the matrices for that. On the basis of that, we can check out the performance of our model. For this, we are calling the ROC underscore AUC score, and these score help us to validate our model. For this, we are calling the confusion matrix, and confusion matrix for we are using calling confusion underscore matrix in the sklearn, and we are checking the number of white under the testing and number of Y's under the training phase. After that, we are calculating the positive or negative ratio that the particular score that our model will have, and then we can evaluate the accuracy of this particular model. I again repeat all this one. We are calling the logistic regression model. This is the code that every time whenever we are implementing this logistic regression, we have just to give this one, because in the previous one we have defined what is X train, what is Y train, and these variables are going to pass on this logistic regression. After that, we go for the training epoch phase, and after that, we are testing that model. And after that, training and testing, we are validating our model accuracy with the confusion matrix. So let's run this one now. It will take some time. Just wait. Could not convert. Okay, I think I have missed some of the string earlier because I have converted it data type as well. Just wait. I have missed some string over that earlier because I had checked that yesterday. The everything is corrected, that one. I have missed something. Okay, I will check it out where I have missed. I have missed some of the cells so that it will continuing from the upper one because it is a pipelining. So I will check it out where I have missed that one so that we can figure out and we will get the exact result what we have. So after that, we will get this kind of result. I will check, recall the entire project again. So after running that one, it will give you this kind of data. So what is this data? Let's discuss. So it will provide you the number of training. It will provide you how many training percentage and how many testing percentage, and it will provide you ROC score and your ROC for the test and train. On the basis of that, it will provide you the confusion matrix. And this indicate that out of the 2000 in the testing rate wrong, it will pick out this 417. And on the basis of that, it will calculate the kappa score for the accuracy matrix for your model. And it shows that this model accuracy is 62%. When you convert it into the percentage, it will provide you the 62%. So this is the way in which we can able to train our model using the logistic regression. And I will check out, I have missed some of the cell. That's why it is not passing on the, because in the pipelining, we are having output of one stage passes as an input to the other stage. If you missed any of the one, so you will have missed out something. We will find out later. So the next model I am having here, the naive Bayes classifier. The naive Bayes classifier is the next supervised learning approach. I will show you little about these models so you can have an idea. Just wait. I have opened these pages for your presentation as well. So logistic regression is the simplest one. The next approach we are using here, the naive Bayes algorithm. It is used under this supervised learning approach. It is basically used for the classification problems because here we are using to predict customer churning problem only. So why we are using the naive Bayes? It is basically a probability based algorithm. So it is basically based on this probability algorithm, so that if you want to going to predict, it will find out all the cases, case A, case B, case C. So it will find out all the sample space. So on the basis of that, it's going to give you a hypothetical prediction. It is true or false that particular person is going to churn you or going to with you. So this is the naive Bayes approach that we have applied in this. Again, I'm going back to my project. Under this, I have called the Gaussian naive Bayes approach here. I have called this model Gaussian NB. Gaussian NB means Gaussian naive Bayes classifier I'm using here, and I have stored that model in the variable NB. After that, I'm checking that model for the fit for the X and Y train category as well. So after that, we are going to train the model, passing all the training parameters to the naive Bayes classifier and going to predict the values. And after the training will complete on, we will finding out the same for the testing case. So testing again, we are using the nb.predict, but here we are replacing the testing set here. So after that, this training will take little time, 1 to 2 minutes in case of machine learning, and many days in case of deep learning. So in this case, after the training and testing phase, again, we need to check the model accuracy for the testing phase. So model accuracy, again, we are using the same accuracy underscore score for the training as well as the testing. And again, we are using ROC and AU curve to find out the number of areas that are covered in the this phase, number of points that are covered in this area. Then we plot a confusion matrix for the same, and we finding out the total number of wrong prediction and check the overall accuracy. So when you run this one, again, you will get a summary of your model like this. So see, this is line, just wait. So this line will provide you this dot, 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 this dot, dot, dot line. So first we have called the model accuracy of the train is 78, model training accuracy on the testing is 79. Then we check for the ROC curve, the number of points that cover in this area. After that, we find it out the confusion matrix, and we will find out the number of wrong prediction done by this model. On the basis of that, the final kappa score we can find out. So in this way, we can find out the model accuracy, and we are training and testing our data using the naive Bayes classifier. The next we are having the decision tree classifier. It is again the supervised machine learning approach. And under this, we are calling the decision tree classifier function to call the decision tree machine learning approach. If you want to see what is decision tree, so let's move to the presentation. Yes. So I will show you what is decision tree. Just wait. Decision. Yes, this is the decision tree. Decision tree is what? Whenever we are having some data point, we are having multiple options that we will go along with the true, or we will go along with the false. We are keep exploring the data for the same, and we will at the end we will move on the particular decision that particular customer will remain or will churn. And this is the output of decision tree. On the basis of the decision, we are going and we are moving around of that, and we are finding out that this particular graph will show you particular aspects of your data and particular decision that you have changed for your data points. It is available for the classification as well as the regression also. To decision tree we are using, it is particularly a non-parametrically supervised machine learning approach used for classification and regression. This is used to predict the value of the target variable by learning the simple decision rule inferred from the data features. If feature one is there, for example, we are having age, we are having estimated salary, we are having the number of product, we are having the geographical area factor. So on the basis of that, we are keep exploring these factors, and we are going to predict one value on the basis of that data. So how to implement this in our project? We are having to call this function decision tree classifier. Decision tree classifier is the name of the machine learning model that we are going to use here. So decision tree classifier dot fit and X and Y are the parameters that we are going to use for the training and testing purpose. And we store the output of this model in the variable DT. So that's why we call DT dot predict for the training, DT dot predict for the testing phase. So after that, we will check the training and the testing predictions and then go with the accuracy score and the ROC score and the confusion matrix for the model decision tree. So again, I'm repeating, this is the decision tree model. We are checking for the training and testing. We are training the model under this. We are testing the model under this. And after that, we are checking the accuracy score of the test prediction and the Y scores. Then the number of points under the ROC, area under curve. Then we finally conclude the conclusion matrix. On the basis of that, we will check the number of wrong prediction and finally the kappa score is there. If you see this, the output after checking out this, to notice one thing that we are getting the 100% accuracy in decision tree. Decision tree is the machine learning approach that is almost and most of the time suffering from the overfitting problem. Overfitting is what? Where we are having all, for example, we are having this curve and whatever the data points, all the data points are covered under this and we are getting the 100% accuracy. This decision tree are most of the time are suffering from this kind of problem. That's why this model accuracy graph show that this particular model has successfully identify all the correct do the 100% accurate prediction, but it is not followed at all. So I'm just giving you the comparison of the various machine learning models under this example. So this is not recommendable to go with the decision tree because we know all that it is not possible for the 100% accuracy and all the points for the overfitting purpose. So the major version of this, the improved version of this decision tree is the random forest classifier. So we will go with the random forest classifier.
Excuse me, Doctor.
Yes.
Can I ask a question? I'm very sorry. It's quite noisy where I am, so that's why I wrote the question on the chat.
Ma'am, please repeat.
It is very noisy where I am. I wrote the question on the chat function. Can you please respond to it before we get to the 100% accuracy?
When you are, I'm reading the question that is in the chat box. We are looking at the result, the number of wrong prediction. You see the conclusion I have drawn. It is a dropping column affect the accuracy. No, no, ma'am. The dropping the column is not going to affect the accuracy because we have dropped only those column that is unnecessary for us. So it will not going to affect your results in the model prediction because in the model we are just taking that data that is necessary and we are using only those relationships that we are looking for. So this accuracy depends upon the number of data points, not upon the number of columns and number of rows. It will depend upon the quality and more number of data will provide you the more number of accuracy. Less number of data or biased data will suffer from the overfitting and underfitting problems, ma'am. So if you see, I have discussed about this decision tree. It provides you the 100% just because that this problem model has itself a problems in that it is always suffer from number of problems. It is not recommended to follow the decision tree. So the advanced version of decision tree is the random forest classifier as well. I'm also going to show how it looks like and why it is more advanced and more preferable. Just give me a time. This random forest classifier, instead of single one decision tree in the random forest classifier, we are having a multiple decision trees. And they are having the number of random nature. So we are having, instead of one decision tree, we are having a forest of decision tree, and on the basis of that average we are going to predict. So it is the better version of decision tree. Decision tree model in the machine learning is suffering from the overfitting problem. That's why we are not using it. And random forest is the advanced version of decision tree that have a better accuracy as compared to the decision tree. These are the very simple links that you can explore and you can understand. Just wait, I'm exploring this for your sake. So you can able to practice this all. So there is a simple explanation. What is the random forest machine learning algorithm? That is the next phase we are using here. It is an ensemble learning approach. It is a classifier, contains the number of decisions. Instead of one decision tree, we are having more than one decision tree. And we are taking the average of these decision tree to predict the better accuracy of the data model. So this is the example. See here, there is a decision tree 1, 2, and dot up to n. It means we are have n number of decision tree, and we are taking the voting of these, and we are calculating the average. On the basis of that, we are going to predict here. If you explore this link, so it also give you this example also. This is the data. We are having number of trees, and we are getting the majority of the voting, and we are going to predict it. So it has the simplest example with the data set. You can find out, you can practice your own, you can learn from this. It is very easy to implement these models because we are having only one line code for this machine. You just need to understand what is this model, how it works, and what kind of prediction and what kind of accuracy it will provide. It is more important. So this is thing. I will share you all these links so you can understand this. And because 2 hours, it is very small and very less time to discuss all these model in very, very detail in the mathematical concept. So I'm just trying to cover all the basic aspect of these model and how to use it in your code. That is the main objective in my presentation. So I just want to familiarize you with all this, how to use this for the particular example. So the code will remain same, code will not change, aspects will be changed upon the data. Every time whenever you need to call this particular model, the same code will be used, random forest classifier.fit. And for the training, we call at that the object of this model dot predict, object of this model dot predict, one time for the training part, other time for the testing part. So after that, whenever you are using any machine learning model, every time we are validating it. And validating on the basis of accuracy score, and for use we are using the ROC as well as the confusion matrix. So after that we are calculating the total number of wrong and false prediction, and we are finding out the exact kappa score. That is also a variable. Just wait, I'm showing what is kappa score. So you will understand why we are using it. Just give me a minute. So this is the kappa score. Why we are using it? Kappa statistic. It is this formula going under this kappa score. So we are finding out the true positive, true negative. Just we are finding out this score. This is the confusion matrix. And after that, we are checking how much this particular score is reliable and how much your machine learning model is efficient for you. So basically, kappa score is what it can define as the metric used to measure the performance of machine learning classification model based on assessing the perfect agreement and disagreement between the real world observations and the predicted observation using that machine learning model. So that's why we are calculating these accuracy scores every time so that we can check out how accurate and how good your model performance is. Yes. This is the random forest classifier, and when you run this one, so in this what we get, 100% training is done, and testing, these are the 80% testing is done, and the accuracy score for the training is 100%, and for the testing we are getting the 73%. So on the confusion matrix we are getting this number, and we are checking out here, out of 2000 wrong prediction is for 256, and in the logistic regression if you compare, it was 427, it was 417. So if you find out the productivity of random forest classifier is much more better than our earlier machine learning models, because the wrong prediction cases are only 256. So we are improving the accuracy of our model here. So I think till now it is okay with you all. So we will explore the another model, that is the KNN classifier. So next model that we are going to use with this project is the K nearest neighbor classifier, KNN classifier, we can say that. So for this, we are going to call the function K neighbor classifier dot fit. This is the name of the model that we need to call. Again, we are going to provide the X and Y train parameter. And after that, again, we call that object KNN that we have make here, and we are going to call this function for the training, and we are going to call the same for the testing. So see this, every time this code is same, every time model name dot predict for the training, and for the testing we are doing, just we are changing the model name here and dot fit. X and Y is also remain same. So if you just want to run that, it is very, very easy to implement that model. But if you want to understand, you need to understand the basic logic behind it. So I'm sharing the some of the links, so where you can detail understanding of that model with the suitable examples that I had given on that link. Okay, so KNN, basically KNN is a classifier. It will going to classify the number of data points upon their different categories, and after that it will take little more time as compared to the other, because it will going to classify the different classes and segregate all the points in the different clusters that we have seen the example in the case of unsupervised machine learning. So again, the same matrices used for the accuracy score, ROC curve, and the confusion matrix as well. And after that, if you see, this has low accuracy as per the previous random forest because of the number of data points that may be misaddressed here during the training, and the total number of the accuracy score of this model is 81% in the training phase, 77 in case of the testing phase, and ROC we are finding out the number of areas that number of data points that cover under this area. It is the 59% and 50% in the training and test case. After that, we are finding out the confusion matrix, and we are overall calculating the wrong prediction for the here is the 459. And the kappa score overall, see here, because the number of wrong predictions are more in case earlier we are having around 200 something, now we are having around 450. So the accuracies of this model is very, very less. It is only 22% only. So that's why we need to refine this or hypertune later on, depend upon the data or depend on the feature we are looking for. The next model we are going to implement is the supervised support vector machine. Is the support vector machine. For the support vector machine, we are calling the SVC, and we are using the linear model here. we are, because it is having the both model for the linear and non-linear. In this case, we are calling the SVC the sport vector kernel. So we are calling that, and we are using the linear model here. And after that, we are calling that object for the model dot fit for the train X and Y train. And again, we will going for the testing and training phase as well in SVM. I will also show what is SVM. I have covered that in the presentation as well. Just wait. So sport vector machine. Yes, sport vector machine. Sport vector is what? It is basically a numerical value. For example, I'm showing you here. We are having data points here. For example, we are having some data points. We are having some data points that is gathered or scattered somewhere in the space. So what is sport vector? In the linear regression or logistic regression, we are just getting this point. What is the sport vector? Sport vector is the area where we are going to distinguish. These are the values. See here. Sorry, my line got distracted. This is the line. So in this sport vector, we are finding out these line points. We are drawing here 2 line points, and these lines are known as the sport vector. These lines are known as the sport vectors. These are the points where we can able to create a marginal or boundary line to able to distinguish to these type of different data points. So I'm showing you one example here also, so you can get it more better. Just wait. So see, these are the supporting points. For example, see this. So this is the sport vector that is able to linearly divide this point into 2 halves. This is the 1 half, this is the second half. We can able to find out if the point lie under this region, we call it as the 1 category. If point lie under this, we call it as the second category. This is the linear. This is the linear way, and other we are having the hyperplane where the linear phase is not possible. So at that time, we are having the another approach, that is the hyperplane. So we are going the 3-dimensional space to checking out the multiple sport vectors and finding out that sport vectors to linearly or non-linearly divide the data into the multiple data points. So this is the hyperplane that is shown in this diagram, and this is the linear sport vector that is shown in this diagram. Sport vector basically is the point that we are looking for that can able to divide our data into the 2 different parts. So that we are going to check. Just wait. So that sport vector we are going to implement here using this code SVC. And the model we are using here, we are not using the hyperplane here. We are using the linear plane here. We are using the linear problem here. So in this, we are checking here the SVM dot fit. Under this, we are putting the X train and Y train variables for which we are calling this model. And after that, again, we are training this model using the training data set. And after training, we are calling for the testing of this model. And again, every time, whenever we are using the testing and training, we will call for the accuracy score. And I will also explore this key how this ROC and the confusion matrix going to do calculations and provide you the overall accuracy of your model. So when you call this sport vector machine, I repeat, I am using the linear model here. I'm not using the hyperplane one. We are having multiple options here. So for this, the model training, it is the 77% in the case of training, 78% in the case of testing, and ROC is about 50% range, and this is the confusion matrix. And again, we are having 424 are the objects, that is are the misclassification, and the accuracy of this is very, very low in case of 18% only. So one more model that is the advanced model in the machine learning that we can further go for the hyper tuning. I'm just giving you the simple example of that is the XGBoost classifier. We have number of things that we can implement in the machine learning model. We are having number of models. So just if we are going with the simple example, implement all these models, you can able to find out the variation and the difference between and the working of these models. To calling this model, it is very, very simple. Just to remember the function on which we are using this one. So for implementing the XGBoost, we are using the XGB, and it is a classifier, XGB classifier dot, and we are calling this one, and we are storing the output of the XGBR in this variable, and we will calling for the training purpose also. And after that, we are using the testing phase also, and we are again going to predicted one. And if you see that the model accuracy will increase in this case. So here in this case, we are having a very less, and there are two models provide a very good performance here. One is the random forest one, and second one is the XGBoost, that is the 268 here. So after that, there is a number of options. You can go for the hyperparameter tuning. If you understand these basic concept, then you can understand if your model is having a low performance or not at per your parameters is not giving you that much prediction or that much accuracy, then there is a further requirement of doing the further analysis of your hyperparameter tuning. I'm not going to cover this one because it is a little bit uh, difficult in the first beginning phase. So I recommend you all to go with these implementation that I have covered during this project. Go with the SVM, go with the random forest, go with the decision tree, go with the KNN, go with the simple logistic model. And if you understand these well, you go with this code, then start with the hyperparameter tuning. I will share you this sheet. And once again, I also want to show why I'm using these confusion matrix and ROC. What are these? So let's see. So what is ROC? What I'm using under ROC or AUC? ROC is what? Receiver operating characteristic curve. It provides you the ratio of true positive and false positive ratio. It provides you this these values. For example, TP is true positive and FN is the false negative. So similarly, this ratio can be calculated, and this is the area, and this is the area, this region, and under this area, the number of points that provide you the number of accuracy and the total number of density or the points that cover under this area, that if you have the greater ROC and value, it provides you that we can rely on that project, we can rely on that model for the accuracy as well. Our AUC that we have calculated is what? It is the area under curve. So, and this you can understand. This is the area under curve. So, this is the line that is drawn by this ROC factor that we called in the accuracy model performance, and whatever the points, if the large number of points cover under it means the more accurate the model is. And there are some more that I want to show you all. So these are the accuracy matrices that we have discussed in this way. So precision, recall, accuracy. I'm sharing all these links with you all of you, because in one go to understand this matrix, it is little bit tricky. but these formulas are going under these concepts, and they are calculating just for you. And whenever you are calling this, for example, when you call this confusion matrix, so confusion matrix calculation is going to take place when you call this ROC underscore AU score. So all this calculation just have shown you will take place when you calling the recall score. The recall ratio is going to calculated here. When you call the kappa score, the kappa score value is going to give you. So we can rely on that particular model on the basis of these score, that how accurate your model is and how correct your training is going, and how well your testing training and these phases are running, and you will get the better accuracy and better performance of your model. After that, you are going to predict as well, compare this model performance, and you can able to analyze that which one is better and how and why the model varies and their performance varies. If you, for example, I have only 10,000 rows here, but if I have 10 to the power 6 number of rows, then this model variations accuracy will change, because the more number of data, the more number of accuracy. So you will compare with all these machine learning models, but you able to see that the accuracy is nearly same in that, because the data is very, very large. So model is going to train on the basis of that. So I again repeating that we are having number of machine learning models, and as compared to the that, if you want to find out or find out the performance of these particular models, you can check. If you increase or decrease the size of the data, the accuracy also change. So it is not always sure कि whenever I am going to run this one, it will give you the same accuracy. If you change the data, it will change. If you change the number of data points, it will change. If you give it 75-25 ratio, it will range, but the performance will remain static it somehow. So you will get this one. So I'm not going to cover the hyperparameter tuning because it is much higher level. It is not going to cover in very short period of time. So I will provide you this and links you, so you can cover it on later on. If you have any doubt, any problem, you can contact me or you can call Dr. Mayor sir. So I will provide you the solution as well. So over from my side, sir.
Okay, ma'am. Thank you. Dear participant, if you have any question.
I just want to say, sir, machine
Yes,
learning
ma'am.
models, they are large number of models. It is very difficult to cover all that in the period of
Yes,
2
yes.
hours. So
Yes,
I
ma'am, we
will share
understand.
all the links. I will share
Okay.
all these content. So
Nice.
they can practice, because I'm sharing the very simple example. Though are the beginner, they can able to learn very nicely.
Yes, ma'am. Thank you. Because in the beginning, first we need to understand the models, how they are the working, how we can import the file, and how we can apply our required algos for machine learning. So this is very important in the beginning, because once the beginners are able to use simple model, then they can handle a large model, big problem and complex based models. Like one of the example, hyperparameter turning is also one of the complex model. So once the participant are able or hands-on to use a simple model, then they can use this type of complex model also. So once again, if the participant have any question, please feel free to ask from us. Some of the participants are asking about the link. Surely the link
I will provide you
which
everything.
was discussed here will be shared with you, and the content which are being presented here will be uploaded on your account, as well as we have created a Google Drive link will be shared with all the participants yesterday, and the entire content you will find in the same link. So there is no any kind of a challenge to provide all the content which are being presented in this all the sessions, in the coming sessions, as well as in the previous sessions. Okay. So if you have any other question, please feel free, or either you can raise your hand. We have only 6 to 7 minutes. Or if anyone want to give some feedback, open your mic, or also I request you to open your webcam also. Dr. Jatinder, Dr. Vijay, Ramchandra, Jasprit Kaur, Dr. Neeraj Sani, Monica Kumari, anyone who want to share or about the session, your feedback, your views, your thought. I think if everything is going well, please feel free. And also, if you can open your webcam for having the screenshot. Jasprit Kaur, madam, can you put some views about the ongoing this activity?
No, sir.
Yeah, I say something about the activity if you are enjoying all the sessions. Yes, Dr. Kiran Kaur, ma'am, Shashikar.
Sachkal sir,
How is going this program?
it was a very practical session.
Okay.
Your resource person, she tried to give us the insights of how to work with the project, and that was really good to see. So once we get the things that you are sending to us through the links, we will definitely try to practice all these, and I think everybody could easily follow the instructions given by the resource persons, and they can easily um, get used to these kind of things to do the things practically.
Yes. Do you think that all the sessions are one-to-one interaction? This is very important.
Yes, sir.
Mr.
Every resource
Gaurav
person,
Srivastava, can you remember? Yes, please.
sir, every resource person we had till date, each of the resource person tried to be interactive with the students. Sorry,
Yeah.
students, interactive with the participants. Actually, we are in the teaching stream, na, that's
We
why.
all are student, ma'am.
Yeah, yeah, yeah.
Teacher is always a student.
Yes, yes.
Yeah.
So that was nice because every resource person was asking the participants. That was a really nice thing because even anyone who was having the questions or queries to be asked, everyone was asking in the sessions. That was nice, sir.
Great. Mr. Gaurav Srivastava ji, you want to say something? We are not getting your voice. Please unmute your mic.
This session is very informative and very useful for us. I'm pursuing PhD in image classification. So there's a question, ma'am.
Hanji, sir.
What is the? Can you give me some models in image classification? How can we
Yes, sir.
implement this scenario in image classification? The
Sir,
same way or
I will definitely I will provide you. There is some different technique. We will use TensorFlow instead of sklearn in case of image because we will prefer deep learning in case of image model because in image we are having a large competition. So we will use the tensors and TensorFlow in that way. I have done some of the projects in the healthcare applications where we have some background in the case of image. I will provide you that. If you will have any query in that, so I will also actually sir after 2 hours I need some water. So I'm really sorry for that with thodi problem in that method. So I will provide you that link so you can practice on that and you can try with your own data after that.
Okay, thank you, ma'am. Thank you very much.
Any more question from other side? Okay. If you have any question, or you can put, also you can put your questions or prompts in the feedback form. Feedback form has been shared in the chat box as well as on your WhatsApp group. And I think all the participants who are attending this session are also in the WhatsApp group. So I think everything which we wanted to share with you, you are getting through your email and WhatsApp group also. Okay, so thank you to all joining this wonderful session, and I hope you really enjoy the entire session. Now we are presenting e-token of appreciation to our today's resource person. Um, Ma'am, thank you very much to present your valuable talk on this today's topic, machine learning in practice, featuring engineering, model selection and evaluation, hands-on machine learning project, and some of the examples you present very nicely. And all the participants really enjoyed your entire session. And as we know that this 2-week faculty development program on data science and scientific computing is jointly organized by the Central University of Punjab, Bathinda, Purima University, Jaipur, Nexus University, Abafrid College, Bathinda, and Method Thinking Foundation. Once again, thank you to all to join this session and showing your interest. Tomorrow we will join again at the same time. Stay connected and have a nice day. Thank you to all. Please don't forget to submit your feedback form.